All right, let's go find somewhere quiet. We can talk about Triton and the questions that have come up about it. Alrighty folks, so this seems to be a quiet enough place to have a little quick conversation. So these are a series of questions that have come up online, and I figured I would answer them for you. What is the storage requirements for Triton? So let's put this on here. The Triton requirements for storage is first and foremost is the fact that it has to be kept upright. Okay, the product, as you know, comes with this type of an attachment. You get the hypochlorite in one little bottle, and you got in the other bottle you have a bunch of your chelating agents and saponification agents and surfactants. And so the product is put on, and then you draw from the top. And the issue here is that currently this is just kind of a snug fit here, but you cannot turn that sideways, otherwise you're going to get spillage. And the reason for the spillage is because you need to have air to come in order for you to suck out the product. And that's a question that had come up a few times in terms of spillage. I think that if you are planning on, so what's the workaround for that? If you really have to keep your solution sideways, then I would then recommend that you don't actually put this gasket on. Individually have these holes closed and with the caps, and then just keep them sideways. And then when you need to draw the solution, then you would be actually opening up the caps and then pour equal amounts into a little beaker, and then you draw from the beaker. The volumes that are being added is 1-to-1. This is a convenience factor for you to be able to draw equal amounts of solution through one nozzle. But if it's absolutely necessary for you to keep the bottle sideways, that would be the way to get around that issue. There's a new iteration of this with a new cap that's going to come out. That is going to have a gasket that's going to prevent leakage, so that's going to come down the line. In the IFU, it is explained that you need to refrigerate Triton, but I'll be honest with you, I don't refrigerate it in my practice with the volume that I have. I do end up using it fairly quickly, and I never refrigerate it. So I would assume many people want to put this sideways because they want to put it in a mini fridge in the bottom drawer somewhere like that. So just know that this has a 2-year lifespan in the fridge, but has a 1-year lifespan on the countertop. And to be honest, this is only 480 cc of solution. That means that you're going to end up, if you use 6 cc of solution per case, which is the upper side of the average for people. I, to be honest, use mostly 3 to 4 cc. You will end up being able to do 80 root canals. In my case, it will end up being more than 80. I end up getting about 120 cases out of a single bottle. But for me, in my practice, a busy end of practice, that ends up being one bottle of these approximately per month or so. So I really don't need to refrigerate this. And that's the key thing in terms of how many uses you get out of this bottle. That is at 480 cc, that ends up being about 80 cases if you're using 6 cc, and more if you are using less, which actually you can use a lot less of this material if you use a protocol that I've described in some of the webinars I've done on this product, by using negative pressure to remove the solution in the material before just adding the material to it. I'll probably do another video on that specific topic here for you guys. So another question that come up, what is the pH of Triton? The pH of Triton is about 9, so it's actually a little bit lower than the full strength hypochlorite, and to that extent it's a little bit less caustic. But at the same time, because of the fact that you have more surfactants in there, it can penetrate a little bit deeper, and therefore it is going to be a little bit more reactive, which is part of the reason why it almost catalyzes, the surfactants catalyze the rate of reaction. And that's why I always tell people, if you really believe that this thing is effective or not, just take a little drop of this and put it in the back of your hand versus a drop of full strength bleach on the other side, and you'll see that you feel a little more activity going on with Triton because of the surfactants, because it penetrates a little bit deeper. So another question that come up is, do I need to agitate this product after I place it into the canal? Well, you really have to treat Triton the same way you would be treating your sodium hypochlorite. It obviously works better if it's agitated. It works better if it's heated, but you don't have to do either one of those. You can use it the same way you've been using it before. And that's another one of the more important aspects of Triton as an irrigation solution, is that we didn't try to reinvent the wheel and go out and make a solution that is based on a whole new chemistry of a new disinfectant or a new dissolution agent. This is just 4% sodium hypochlorite when it comes out as a mixed solution. Therefore, all the research and all of the work that's been done on sodium hypochlorite in the past, for the past 100 years, kind of applies here, because the solution that you get into the syringe is 4% sodium hypochlorite with some additional chemicals that help with the chelating agents and surfactants and lubrication agents. So another question come up is Triton less toxic than regular sodium hypochlorite? And again, 4% sodium hypochlorite, you could make an argument that is less toxic than 5.25%, which is full strength sodium hypochlorite, or 6% that you get at bleach from a supermarket. But you know, that still is sodium hypochlorite, so you don't want to extrude it out the end of the road, and it's not really a good idea. You should treat it with the same caution and usually do with any sodium hypochlorite in the past. And so what is the research that's supporting it? There's a lot of articles that are in the press currently are going to get published on this. But again, like I said before, this is sodium hypochlorite. This is not a brand new irrigation solution that will need to be kind of validated in that sense. The same stuff that applies to sodium hypochlorite will apply here, which then draws finally the last question that is also important. And then what is the main advantage of this of Triton compared to sodium hypochlorite solution? And the main advantage of that is the fact that most of the irrigation solution protocols that we've had in the past have been fairly complicated by the use of multiple irrigants, which would require the need for multiple syringes and needles. And here, with the fact that you get everything you need in one needle, the most readily apparent advantage of Triton is the fact that it makes your irrigation protocol more efficient and less complicated for your assistant, in the sense that you don't have to have a bunch of different solutions ordered and mix them up and put them in separate syringes, which is actually the main cost increase of the materials, is the fact that you have to use multiple syringes. The main advantage of this solution is the simplicity and efficiency, which really is the hallmark of Rebuild Endo, and part of the reason why we always try to make sure that we advocate and talk about products that are making your instrumentation easier and more efficient. With that, I hope this Q&A was helpful to you and it helped shed some light on this new irrigation solution. All right, so that's it. It was a quick video on Q&A on the Triton and all the questions that have come up online based on the webinars I have done. Make sure you see one of the webinars that I have done on some of the platforms out there. But I will be slowly kind of trickling in shorter aspects of those webinars in my own videos here on social media for you guys as well. So until I see you in the next video, for Rebuild Endo, I'm Ali Nasir from Chicago, Illinois, and at the Chicago Midwinter Meeting. I'll see you soon, and let's save some teeth.